All right, year 10. So we are currently, I think most of you are kind of getting the gist of this. The good thing is, probability is one of those subjects that sounds like everybody sort of gets here, which is good because you did some of it back in your previous school. Yeah, so that's a good thing. So a lot of what you're learning here, thank you, Charlotte. A lot of what you're going to be learning here is basically a recap of what you did last year. Charlotte, do you have your booklet? Get it out, please. All right. Colin, get your booklet out. All right, so in this session, what we're going to be covering is the next part of probability. So last session, and you should be copying the learning intention in here as well. Okay, so we're up to AP unions and intersections. This page. Unions and intersections. That's the questions already. You need to copy that. So today, our learning intention, okay, is to be able to understand what is a Venn diagram and a two-way diagram. Both of them are connected to each other. There's something connecting, and what is the word mutually exclusive and non-mutually exclusive as well. So that's what we're going to look into, and hopefully by the end of today's session, what I would like you to be able to do, okay, is distinguish between what is mutually exclusive and what's not mutually exclusive. Understanding different symbols that we use in probability, especially with Venn diagrams, and interpreting what a two-way table is. Okay, so copy that down, please. Sort this out. Sorry. All right. All right, everyone good? All right, while you copy it down, do we actually know? Does anyone actually know what a Venn diagram is? The one with two circles. Is it always just two circles? Sometimes there's three. Other times, if you're crazy, there's four. And if you're like doing special or some really high level math, it might be fine. Yeah. But here in core math or general math for year 10, we'll only cover two or three at most. Okay? Two or three. So when we talk about Venn diagrams, it's got those two circles. Chris, can you tell me what else is inside a Venn diagram? What information might you find in a Venn diagram? Good. Something that's similar between both of them. I like that. Similar or something they have in common. Can I ask Tiana what you might find in a Venn diagram? Have a think. So if you've got two circles, yeah, what do those two circles represent, Tiana? Could be the differences or two different things. Something being the same. Good, good, really good words. Who else might I ask? Esteban. What's one more thing you might find in a Venn diagram? So you might find something in common. You'll have those two circles. The same. Oh, I pretty sure already said that. Same, difference, and the heading. What's the heading though? The topic. Could be the topic. It could be the thing that we're comparing. Yes, Colin. The outlier. There may be outliers, so something that doesn't belong. Okay, is essentially an outlier. All those things that you've described are things you'll definitely find in Venn diagrams. Okay, but also and you may have never used them, two-way tables. Okay, also two-way tables. So hopefully, what I'd like you to be able to do is understand how we use them and be able to distinguish between the information inside it. All right. So let's do some tests. Raise up your hands if you study psych. One, two, three, four, five, six. Okay. Um, raise your hand if you study food tech. Okay. There's a few of you. Food tech. Okay. And raise your hand if you do both. Oh, Only Surya does both. And Van. Okay, you got two people that do both. All right, cool, cool, cool. So you can see there are a few of you that do one, a few of you that do the other, and one person that does both. Cool. Raise your hand if you walked home to school. Oh, walk home from school. Or the other way around. Walk to school from home. Yeah, so if you walk. Cool. Raise your hand if you use the car to get anywhere. From school to school. Oh man, lazy. Lazy. I'm kidding. And raise your hand if you do both. Oh, fantastic. Okay. So here's the thing, yeah. Whenever you work with sample sizes in any class or any group of people, what you'll find is there might be two people, okay, that have something in common. So did you did it was it, I think Tiana, you put your hand up for both or no? So Tiana, okay, walks to school but also gets driven to school sometimes. Okay, whereas someone like Sam, do you drive to school? Do you get driven to school? Or do you walk? He just walks. Okay, and some people do the other. Now, when we talk about the word mutually exclusive, okay, what we're talking about is when something doesn't have anything in common. Okay, when it's one or the other. Okay, so when we talk about mutually exclusive, yeah, mutually means something that they have together, but when you say something about the word exclusive, okay, it means that they don't have anything in common. Okay, nothing in common. So when Krish before was talking about a Venn diagram, okay, and you had your two circles, and they have something in common. Yeah, so he talked about, Venn diagrams have something in common, which is that little bit that I highlighted there. Something that's mutually exclusive technically doesn't have that. So if you have a Venn diagram, they are separate. Okay, do you see that? When it's separate, that means they got nothing in common whatsoever. But when they are together, okay, so when you got two circles together, notice how they overlap. That means that there's something that they have in common. So it's not mutually exclusive. So when mutually exclusive, if I was to put a definition here, you can say have nothing in common, or you can say no intersection. Now, I'm not saying this is going to be on the sack, but it's not going to be on the sack. So maybe it's worth writing in here because it's not going to be on the sack. Just saying. Just saying. All right. When someone asks you what does mutually exclusive mean, it means they have nothing in common. There's no intersection, nothing in the middle. Okay, so make sure you're writing these terms down. All right. Any questions about that? So when we talk about mutually exclusive, you're talking about something that doesn't have anything in common with one another. Okay. Although, in saying that, I like that the booklet does provide a good definition of it. If you look at the next slide, I think I'm going to go down. Can I go down now? I'm going to go down now. It does provide a very good definition. So when something is mutually exclusive, you've got two events that have no common elements. Right? Nothing in common. Okay, that's what we're talking about. Have a think about this. What's two events that can never happen at the same time? Anyone know? Two events that can never happen. Yes, Esteban. Good. It can never happen at the same time. It's either rising or it's either setting. All right, what else? What can never happen at the same time? I don't know. What what event can never happen at the same time? What are two things that can't ever happen at the same time? Yes, Alana. No? No, say it. Well, let's correct it if it's wrong. What is it? What is it? What is it? Sure. Okay. Water getting yeah. So water can either be hot or it can be cold. Yeah, that will make sense. Depends on what the event is, because if you put it together, it becomes warm. But still, yeah. What about let's bring it back to maybe what you've learned in probability before with a deck of cards. Can you pick out if I was to pick out one card, can I pick a black card and a red card? No. That's what you call a mutually exclusive event. It can't happen at the same time. What about, can I get a number card and a face card? Is that mutually exclusive? So a number card and a face card, mutually exclusive. You can't happen at the same time. Now think about this. Can I pick a card that's red and the number 5? Is that mutually exclusive? No, good, because it can happen at the same time. Okay, so when you look at this, thank you. When you look at this part here, mutually exclusive are events that cannot happen at the same time. No common elements. That's probably the main thing that you're trying to get out there. There's nothing that they have in common. And I drew this for you guys here before. Yeah, the circles are separate. They're not together. Now, in terms of notation and how we represent that, over here is what you probably need to be copying in your booklets. This symbol means they're mutually exclusive. Okay, that little symbol. Color that in for you. Okay, so this symbol means mutually exclusive. Okay, so put that in there if you haven't already got it in there as a symbol. Let's make this red. All right, put that in there, please. So the thing I've highlighted, you want to put that in there. Now, and we'll get into this a little bit later. When you look at then, if you put the probabilities of them together, probability of A intersection B, it equals 0. What that means is they essentially have nothing in common. There's no intersection. Okay, I'm going to put that here. And I want you to actually write this down. Okay, no intersection. Okay, nothing in common, no intersection. Sorry about the writing, it's a bit horrible. Okay, but you can see that there's no intersection. They don't have anything in common whatsoever. All right. So remember that for when we say mutually exclusive. Okay? So if I ask, Kane, what does the word mutually exclusive mean? I've been banging on about it the whole session. What does it mean? Read it. Tell me. Yeah, man. It's on the notes. What does it mean when something's mutually exclusive? It can't happen at the good. Okay, mutually exclusive can't happen at the same time. Doesn't say that there, but that's what I've been saying this whole session. All right, I'm going to move on. All right, here we go. So I've sort of used cars as an example, so let's go and use these ones. Which pairs are mutually exclusive? So drawing a red card and a king, is that possible? Yeah, so that means this one is not mutually exclusive. Okay, because it can happen at the same time. Remember, mutually exclusive means cannot happen. All right, event A. Okay, let's have a look at this. Event A, you've got 1, 2, 3, 4, 5, 6. And event B is 10, 12, 13, 14, 15, 16. Now let me ask, Georgie, do these events have anything in common? Event A and event B. Do they have any numbers that are the same? No, so that means this is mutually exclusive. Okay, because they can't happen at the same time. Okay, let's put that down. So event A and event B, they have nothing in common. So that means it's mutually exclusive. All right, let me ask Lizzie, because she's about to fall asleep. Can you tell me event number 3, if you roll a 3, 5, or 6, or an even number, can you tell me, is that mutually exclusive, which means they can't happen? Or is it, they can happen, and then mutually exclusive means they can't happen at the same time. Which one is it? Good. Why is it mutually exclusive? Tell me. Yes. Well, actually, 6 is not an odd number. 6 is an even number, which means that it can happen at the same time. So that means it's not mutually exclusive. A bit confusing, I know. You'll get the hang of it. Okay, so remember, mutually exclusive means it cannot happen at the same time. When you say it's not mutual, it means it can happen at the same time. You can probably think of other events for this, but let's just stick to that so that I'm not talking too much. Let's move on. Now go to this one, Venn diagrams. Now we're going to get into the Venns. The Venn diagrams, okay? So when you guys talked just before about what Venn diagrams are, they are indeed a visual representation, and there's a lot of things you can find in there. As Stefan mentioned, you might have the title. This one doesn't have the title, but in here, I think what Esteban may have meant is the titles of the events. Yeah. So in most Venn diagrams, you'll have two events. You'll have normally two circles as well. What Chris mentioned before is they might have something in common, which might be the middle. Okay. And I think it was Sam. Someone mentioned that there might be outliers. I can't remember. Someone mentioned it. Outliers. Something that doesn't belong. Here it's not shown, but that could be the case. Now, with most Venn diagrams, like I said, you're only going to work with two circles. Okay, so like this. Event A and then event B. And then what they'll get you to do is you need to list down the numbers within the actual Venn diagrams. Yeah, so you need to write them down in there. Now, you'll see this symbol as well. So I'm going to highlight this. This here, little backwards 3 symbol, just means universal. So what that means is when you add them all together, that's how much of those numbers there are. Okay? Adding them all together represents how many numbers there are. That's what that means. And I'll get into that shortly, okay, what that means. So that little squiggle. Normally, you'll find that up here somewhere in your Venn diagram. So in here, they've put it up here. I like to draw it outside of the Venn diagram here, but it really doesn't matter. As long as you write a little symbol that looks like this, yeah? It's like a little backwards 3, and you tell me how many numbers all together. Okay, and I'll explain it shortly. Over here, more symbols. Whenever you see, and I'll highlight them for you because you're going to need to know them. Again, I'm not saying it's on the sack, but it's not on the sack, yeah? This represents A intersection B, which represents this middle bit here. Okay, so Attila, if I ask you, what does A intersection B mean? What does that mean, that middle bit that I've highlighted? What do you think it might mean? It's okay if you get it wrong. It's not an issue. But what do you think it means? Intersection. Okay, that's all right. Anyone else want to try? What does the middle bit mean? Kira, you want to try? What does that middle bit mean here? Yeah, the thing that they have in common. Good. So when you say A intersection B, Van, what does it mean? No. A intersection B. The middle, what they both have in common. Now, what Van mentioned before, though, A union B would be everything together here. In the circles, though. Everything in the circles. That's what that represents. Yeah, we'll get to that shortly. There's different symbols. I think it shows you. We'll do the worksheet for that later on. The other one is what? Does anyone remember what the dash meant? Little dash on the side of a letter. Not congruent. I think there's another word for it though. It starts with C. It's complement. A complement. So what that means is everything that's not A. That would mean then everything that's just B only, as you can see, and then everything outside. Okay, so keep that in mind. Everything outside as well. That's not A. Although you don't need to highlight it because it's already there. I'm just making a point of it here for you guys. Okay, so keep that in mind. A complement, everything not A. All right, let's go through this and actually do some Venn diagram questions, and then you guys can start some worksheets. All right. All right, you need to copy some of this down, yes, to make sure you're following along. In this question, we're given a scenario where you've got two subjects. Kane, what are the two subjects here? What are the two subjects? English and maths. Okay. Can I ask you then? What do the numbers tell you? What do those numbers tell you? It's the people for what? Yeah, the people for both English and math, depending on what they're like. Okay. Now, according to this, how many students do we have? What's the total, guys? 19. So what I like to do is somewhere up here, I always like to just put the total to tell me that if I add all of the numbers up, it's going to equal 19. Okay, so Tiana, I'm going to ask you, 7 plus 6 is what? Really quickly. 13? Yeah, and then what's 13 plus 6? 13 plus 6? 19, which is correct. So when you add all the numbers together, it should always equal the universal set. Yeah, if it doesn't, then something's up. Okay, so according to this, 19 students were surveyed, 7 liked math only. So that's where we see here, just 7 in math only. 6 liked English only, so that you see English only there. And then 6 students, and this is where Attila was kind of getting there, liked both, the intersection, the middle. Okay, and then when you add them all up, it should equal 19. So let's work out some probabilities here. The probability that people like math only would be 7 out of 19. If it's not there, you copy this down. People that like math only should be 7. So out of a total, it's 19, so it would be only 7 out of 19. That would be that. All right, shh. Now, the next bit here is what's the probability that they like English? Now, this is interesting because it doesn't say like English only. It's like English altogether. How do we get the number 12? Does anyone know? Yes, Donovan. Good. What you're actually adding is this, because this circle represents everything that's English. So you've got to go 6 plus 6, which is 12 out of a total 19 people. Okay? All right, just keep that in mind. Now, the last one there is what's the probability that they're like English or math but not both? So what's that adding? Zero, did you have your hand up? No? Kira? What is that? So the 7 in math only, good, and the 6 that are in English only. That's how you get the 7 and the 6. And always put it out of the total in the end. Hence why I like to put the total, because just to remind you that it's out of 19, yeah? So it's out of 19. Yes? It has to be 19, yeah. Has to be. All right. Now, and if it wasn't the case, then there might be something wrong. All right. Does that make sense, guys? I might. Actually, I won't add another one. Actually, let's add one. What's the probability? I'm just going to add it here. And what does this mean? PR of M. What does that mean? All of math. Yes. How much is that? 13. Yeah, because it's all of math, which means all of the math circle. It's all right, Abby. You'll get there. So it should be 13 out of 19. How about this? Yeah. PR. What does this mean? What does that mean? Everything but math. So what would that be? 6. Good. Why 6? It can't be 12 because what does this involve here? It's also both. So you can't include it. It's just not math. And then if I work backwards and said probability of not English, okay, it's just 7. Good. Okay, I like it. You guys are getting it. Okay, I think that will be it for that. So let's start with some of the worksheets. Now, I did all the things I highlighted. Yeah, you're probably going to be using it in the worksheets that I've given you. So you're going to do worksheet 1 and worksheet 2. Okay, so let's do those. Worksheet 1 and worksheet 2. It's in your booklets.